Welcome to everyone. Hello everyone. Welcome to my Strength of Materials course. I'm solving a question as shown here. There is a simple beam. 10 kilonewton is acting at the midpoint of this beam. There are two supports, pin supports and roller supports. And the question is find normal and shear stress values at point X, Y, and Z. Firstly, I'm just drawing my coordinate system. Since bending occurs at downward, downward, since bending occurs downward direction, I'm just drawing my coordinate system like this: positive y-axis, direct downward as you see, and positive x-axis here. Now I need to find maximum moment values and maximum shear force values. The formulas are written between parentheses. So let's draw the free body diagram for this beam. There will be a vertical reaction VA and the other vertical reaction VB. And now I need to find unknown values of VA and VB by using my statical equilibrium equations like total moment values, for example, about point A will be equal to 0. By applying this equation, I'll be able to find the value of VB easily. All right, here it is. 10 kilonewtons times 5, which is clockwise direction. So I just determined my clockwise direction, as you see here, positive. And the negative, which is counterclockwise direction, VB times 10 is equal to 0. All right, from the equation, I easily get VB value as 5 kilonewton. And the other equation, which is the total forces, the resultant of total forces occurring y-axis will be equal to 0, and the upward direction will be taken as positive here. So let's write VA, which is unknown. I need to find it by doing this equation. That's why I'm writing this equation. So the minus 10 plus VB is equal to 5 is equal to 0. So if we organize the equation, VA will be obtained as 5 kilonewton again. So I know all the unknown variables right now. I can easily draw shear stress diagram, shear force diagram and moment diagram. All right, let's prepare our line for shear force firstly. So I know that at the beginning of the beam, which is point A, I have VA value, upward direction, with the 5 kilonewton of value. So I need to come here as 5 kilonewton, and I need to check whether I have a shear force on this beam, another shear force. No, I don't have any shear force until I have a point load of 10 kilonewton. So I will just go constantly to the point where applied 10 kilonewton, and right there, since there is a point load downward direction, I mean the minus direction, minus value, I will subtract 10 from 5, and I will result with the value of minus 5. And when I continue to check whether I have a shear force one more time, no, I don't have. Till the end of the beam, which is point B, I have one shear force there, which is VB value to upward direction. I will constantly go there and to upward. Here is my shear force diagram, and the unit will be kilonewton. All right, now it's time to draw Moment diagram with a simple beam with a point load is quite easily actually. It can be easily memorized like here. For the moment diagrams, the downward red line will be positive values. I know that the maximum value occurs where the point load is acted for these types of beams, and it's gonna have the shape like this. Actually, there will be a little bit more calculations, but I'm not doing it right now. If you want to draw, actually, there are very simple more calculations by drawing moment diagrams, but it's a different topic. I didn't focus on that part for this question, so I know that the value of maximum moment for this beam is 10 times 5, which is 50 kilonewton meter. Now I draw my shear force and moment diagrams. I'll just substitute the necessary parameters into the equations of sigma and tau equations, and after that I'll get to the conclusion. So I determined my values, my maximum values and Vy values, they are knowns. So the average value of y is also obvious. It can be obviously understood from the rectangle cross section as 60, since the height of the beam is 60 millimeters and it is symmetrical over x-axis. I can easily get the average y values 30. So actually, all right.